Okay, so there's two types of notation. We've already looked at this part today. That's f prime of x, or you could just say y prime. That means find the derivative. The other type that we're going to use a lot is what we call Lightness notation. Gottfried Leibniz is one of the co-developers of calculus, along with Isaac Newton in the late 1600s and 1700s. And we say dy over dx. And the d stands for derivative of y with respect to the variables x. And we'll talk about what that means a little bit. So I'm going to go through, I think I'll have time to talk about a couple of simple rules here. And I'm not going to do a proof on these things, and I don't think it's important for this class, but it basically just means a constant function rule. So if you had, like, for instance, let's just write this down just for reference. Let's just say you had f of x equals 5. Okay, tell me what the graph of f of x equals 5 looks like. Okay, what is a derivative? A derivative is a slope of a tangent line. What would be a tangent line to every point on that graph? It would be the same, wouldn't it? And what's the slope of a line if it's like that? 0, right? Okay, so what we'd have is automatically f prime of x would be 0. Anytime you have a constant, f prime of x is 0, okay? You want to know that automatically. You don't want to do no difference quotient on that, okay? What if you had g of x is equal to 1/3? Is that a constant function? Yep. What's the answer to the derivative? 0. Okay, that's what the constant function rule is saying, okay? Now, the power rule goes like this, okay? So it goes like this basically. If you have x to a power, and that power can be anything, any number, then what you do is you bring the n down, you just kind of knock the exponent off and put it down, then you subtract 1 from the exponent. So let's write just down a couple of simple illustrations on this. Let's say that we have x to the third, and let's say that we have, and we just want to do like, say, x to the 10th or something like that, okay? All right, if we were doing this problem right here in the difference quotient, well, you'd have to put it in that big formula and do all the algebra. Now you can do it in your head. So here's what you do. You knock that off, that becomes 3, and then this exponent always goes down 1. So where is that now? Problem done, okay? Isn't that cool? Okay, I'm not going to show you why. That's not the point in this class, but just to know how to do it. Okay? So what would be the derivative on the next one? You do the same thing. 10x to the 9th, right? Okay, goes like that. Knock the exponent off, take away 1 from the exponent, problem done. So that's really nice. You're going to do that throughout the class over and over and over again. So you want to know how to do that, okay? All right, so we're going to just kind of finish up here by looking at some basic derivatives here, and I'll probably do a little bit of work with exponents also. Okay. That's a constant function, isn't it? Right? So what's the derivative? 0. Good. Okay, example 2. Is that a constant function? Yes. What's the derivative? 0. Okay. How about example 3? That's a constant. 2 pi is a constant. Pi is not a variable. That's about 6.28. Now this time I want you can write it down as y prime if you want to. You just say y prime is equal to 0. Okay, because I wrote it as y, I didn't say f of x. Okay, how about the next one? What's its answer?
5x to the 4th.
5x to the 4th, good. That's a power rule, like that. That's how you do it. Okay, those are pretty simple. Okay, all right, let's kind of go through and look at, I want to probably just review, see if we can finish up by doing these things here. This is some algebra background things that you want to make sure you know. So for instance, if we have this property, let's write down an example like this. If you had x to the negative third, and hopefully you know this from your past. If you don't, it's something you got to get ironed out pretty fast. That's the same as 1 over x to the third. So if you have a negative exponent, that's how you make it into a positive exponent. You just put it in the denominator, okay, like that. Okay. This one right here would kind of go like this. This would be saying if you started with 1 over x to the, say, the negative 4, then if you bring that to the top, its exponent just changes to positive. Okay, is that stuff you've done in your background? Because you'll do this constantly in calculus. You've got to know how to do that. You also want to know that a square root is a 1/2 power. Okay, I'm not going to write anything on that because that's what you do. You change square roots to 1/2 power. Let's actually write something down like this. Let's say you have square root of x plus 1. Well, you would write that as x plus 1 to the 1/2 power, like that. So you got to know how to change radicals to exponents and back and forth. Yes?
Does that go for like open root?
Yeah, okay. Yeah, well, you're fine, okay? All right, let's do an example on this. Go ahead.
Let's say that's a 3, if you have a cube.
Like a cube root, then it would be a 1/3 power. That's what I'm getting ready to show next. A 4th root would be a 1/4 power and so forth, okay? So what if you had the 4th root of x to the 3rd? You have to write this. See, the name of the radical always is the denominator. Then that goes like that. So that's x to the 3/4, okay? I don't have time to spend much on this. It's just you need to know how to change radicals back and forth to exponents. So you'll do it constantly. It's not that big of a deal. Okay, let's do just a couple of derivatives here. So this one right here is something to a power. Now this is the Leibniz notation. If you see d dx, that's just telling you to take the derivative. So what you do is you bring the -3 down, okay? Then you make the exponent go down 1, okay? Which you can do in your head. So that would be, as an answer, -3 y to the -4. That is your derivative right there. Same thing. That's a power rule. Bring the exponent down, make the exponent go down 1, okay? Okay, the next one. Now this one has a mistake. That's supposed to say d dx of 1 over x to the 10th because the variable's got to match. Don't worry about why that is. Okay, now the thing on this one is you can't just do the derivative of top and bottom. A lot of times students think you can just do derivative of top and bottom. You can't because all you know how to do right now is x to a power. So what happens if you bring the x to the 10th up to the top? What does it turn into? X to the -10, right? So we're really doing the derivative of x to the -10. So you have to start the problem that way. Okay, can you tell me what the derivative is in your head? -10, x to what? There you go, goes down 1, good. Okay, so it's the same idea. So that goes down. And again, you just do this in your head, but remember you're subtracting 1, so you get -10 x to the -11 like that. That's how it goes. Okay? So that's the power rule. So I want to at least make sure we got kind of the power rule under control today and then the constant rule. Okay? Those are pretty easy things to learn how to do. Okay? All right, so tell me what the derivative of this is.
12 x to the 11.
Very good. You can go. Okay. If you didn't have that one down, I was going to make you stay. Okay. Have a good day, and I'll see you Thursday.